A very good morning, students. This is 11th standard mathematics, and in the previous class we started a new chapter number 10, differential calculus, differentiability and methods of differentiation. And we have seen the introduction of this topic. Differential calculus is nothing but calculating the rate of change of various things. Differentiability, whether the given function is differentiable at a point, checking those concepts is called differentiability. And methods of differentiation, what are the methods that we follow to differentiate a function? So these are all the contents of this topic, meaning of the topic. And in the previous class, while giving formulas, I asked you to read all the formulas thoroughly. Hardly 22 formulas were there, starting from constant, that is, the formula is in the form of a table where the first column is function and the second one is its derivative. For example, and we have seen constant k, differentiation answer is 0, x power n, answer is n into x to the power of n minus 1. Like that we have discussed about 22 odd formulas. It is very important for you, before entering in this class, you should thorough all those formulas. How to differentiate also I have just given a brief introduction. For example, if it is x power 6, how to differentiate? Power will come to the front and power gets reduced by 1. 6 into x to the power of 5. And sin x, differentiation is cos x. Suppose if it is sin 5x, what we have to do? Apply the same formula, cos 5x, but in place of x, 5x is there. So differentiate this 5x once again, you will get 5. So 5 cos 5x is the correct answer. Similarly, if we differentiate cos x, the answer is minus sin x. Suppose if it is cos 9x, what will be the answer? Minus sin 9x into 9. Why this 9 comes? Differentiating 9x once again. So these are all nothing but basic formulas, and applying the formulas in some other slightly different function. Sin x and sin 5x are slightly different. In place of x, 5x is present, so we are using the formula that we know, but additionally differentiating 5x once again and writing 5 in the multiplication ends the differentiation properly. So read the formulas thoroughly. Now we will see few notations of differentiation. If f of x is a function, when I differentiate this, I can say f dash of x. F dash of x means differentiating f of x. That is the meaning that we have to take. F dash of x, differentiation of f of x, or otherwise called as, if y is a function, I can say dy by dx, differentiating y with respect to x. Actually, this is not division, this is not numerator, and this is not, we should not take that sort of meaning. The meaning is d by dx of y, that is the meaning. So this stands for the differential operator. This is nothing but differential operator. What we are doing, we are differentiating y with respect to x. So this is not, you cannot think this as a quotient, this is numerator and this, no. This is a single term. The meaning is, out of this d by dx stands for differential operator. What we are differentiating? Y. We are differentiating y with respect to x. So I think you will understand all these things properly. Now we will enter into what we call as into the chapter now, by giving some definition, and accordingly we will see problems related to that. Now the first definition is tangent line with slope m. I'll read out this once again. You just take what is necessary for the problem's sake. First I'll read out this. Let f be defined, f is a function, be defined on an open interval containing a point x0, and if the limit limit delta x goes to 0, delta y by delta x is equal to, actually delta y means change in y, delta x means change in x, where y is equal to some function of x. Suppose y is a function of x. If I write delta y, what is the meaning? Change in y. Delta x means change in x, that is the meaning. And this can be written as f of x naught plus delta x minus f of x naught by delta x, which means this is called change in y, because when will y change? If x changes. Suppose if x changes, instead of saying x, we are taking x naught. Suppose x naught changes, which means it gets added with some small number, x naught plus delta x. This is definitely x naught plus delta x is a number which is bigger than x naught if delta x is positive. Try to understand what I am telling. F of x naught plus delta x is a value which is bigger than x naught. So this is bigger value we are calculating minus the original value. That therefore this is called change in y. Are you able to understand this? Otherwise we will take one example now. Suppose if this, in this example, let us take y is equal to some, what to say, x square plus 3x, for example. Suppose if I am taking y, x is equal to 5 is my initial point, x naught, and delta x is equal to some 0.5. Now what happens if I calculate f of x naught plus delta x? What is the answer? F of 5.5 will come, because 5 x naught is 5, delta x is 0.5, so 5 plus 0.5, 5.5. How to calculate f of 5.5? I should substitute 5.5 in place of x, so I will be getting 5.5 whole square plus 3 into 5.5, right? One value I will be getting, for example, suppose I am getting an answer called what to say, some 46.72, exact, just not exact value, rough value. And suppose I am calculating f of x naught. X naught is nothing but 5. How to calculate this? Put 5 here. 25 plus 15, so 40 comes. Now I am doing this, f of 5.5 minus f of 5. Actually, what is this? F of x naught plus delta x, that is called 5.5, minus this is x naught. Try to understand what I am trying to say. F of x naught plus delta x is a value which is slightly bigger than x naught, and when we calculate this, f of x naught plus delta x minus f of x naught, we will be getting change in y, that is 46.72 minus 40. Some 6.72 is nothing but actual change in y value. So change in y value is 6.72, which is denoted as delta y. So try to understand why I am telling that. So like that, for delta y, we are writing f of x naught plus delta x minus f of, this is how we will calculate delta y. So delta y can be calculated using, if there is some change in x, definitely there will be a change in y. How to calculate that change? F of x naught plus delta x minus original value, f of x naught, divided by this delta x. So this is called slope of a tangent. This is the formula for slope of a tangent. Even I can say that this is the formula for finding the first derivative, dy by dx. Hope you will be getting a little bit confused. Don't get confused. We will simply keep in our mind that this is the formula for calculating slope of the tangent. This is the formula for calculating slope of the tangent, or otherwise can be called as first derivative. So this is the formula for first derivative. Try to understand. So this exists. Suppose if this limit exists, then the line passing through the point x naught comma f of x naught with slope m is the tangent line to the graph. This, even if you don't understand, no problem, because what they are telling us, this is slope of the tangent, then that line must be a tangent line. Since this is slope of the tangent, the line which passes through this point must be the tangent line for the graph. So the slope of the tangent line is also called as slope of the curve at that point. For example, if there is a curve like this, and if this is the tangent, you know very well what is the meaning of tangent. Tangent means it touches the curve at only one point. That is how we have studied. So this is nothing but formula for calculating the slope of this tangent line, where at this point is called x0. Suppose this is x value, what is y value? F of x0. So this is the point, combined point of this is x value, y value. So what they are telling, this formula, if it represents the slope of the tangent line, then this line which passes through the point x0 comma f of x0 is called tangent to the curve. That is the meaning. So throughout the whole page, you just need to remember that this is the formula for calculating slope of the tangent line. Also can be called as first derivative. This can be also called as first derivative. So this can be also called as first derivative, or otherwise can be called as slope of the tangent line. That is what this whole page is telling about. We'll go for the next one. So if at all you get a little bit confused, then we'll go for this problem, and you'll try to understand. If there is any confusion in the previous page, you just try to clarify that using this problem. What is this problem all about? Find the slope of the tangent line to the graph of f of x equal to 7x plus 5 at any point x0 comma f of x0. What they are giving, this is the graph, this is the equation of the graph. We need to find slope of the tangent line at this point x0 comma f of x0. So just keep the formula that we studied in the previous page. This is given f of x. Try to calculate f of x0, which is nothing but, try to calculate f of x0, which means just to replace x by x0, 7x0 plus 5, right? Because what the formula says, I'll write the formula here. What is the formula that we know? The formula is limit, what limit? Delta x goes to 0, f of x0 plus delta x minus f of x0 divided by delta x. So actually this is the formula for calculating slope of the tangent line. That is why we are interested in finding f of x0. So that we are finding f of x0, 7x0 plus 5. Next, what we have to do, this value we want. So f of x0 plus delta x, how to find? This is f of x. So in place of x, you put x0 plus delta x. So in place of x, I need to use x0 plus delta x. So 7 into, in place of x, put x0 plus delta x, and then this 5. Multiplying 7 inside, you will get this line, right? Now delta y is formula is, so this is called delta y, right? The numerator is called delta y. Delta y is f of x0 plus delta x minus f of x0. So first you write f of x0 plus delta x value, put this minus. F of x0 means 7x0 plus 5. Simplifying this, 7x0 minus 7x0 will get cancelled. Even plus 5 minus 5 will get cancelled. So only 7 delta x remains. So divide by delta x on both sides. What happens? Delta y by delta x. Here if you divide, this gets cancelled, only 7 remains. Now what is the formula? Formula is this, limit delta x goes to 0. This numerator can be called as, the other name for the numerator is delta y, right? So delta y by delta x. So limit delta x goes to 0. Delta y by delta x value is 7. Delta x is not there, so we cannot apply this limit, so answer is only 7. If any delta x is there, we can put 0. Since only number is present, we cannot apply this limit, so that number will be the answer. Therefore, the slope of this tangent line is 7. Now I said slope of the tangent line can be also called as first derivative, I said. For example, if the function f of x is given, right, f of x is equal to 7x plus 5. You just differentiate this. F dash of x is equal to, how will you differentiate? What is the differentiation answer for x? In the last class we clearly discussed. If I differentiate x, differentiation of x, answer is 1, right? So 7 into 1 is 7. If we differentiate constant which is present separately, the answer is 0. So only 7. This is called first derivative, which is also comes as the answer here. So what is the concept? We need to find slope of the tangent line. Formula is this. So we are calculating f of x naught and f of x naught plus delta x. Then subtracting the 2, we are getting delta y. After finding delta y, we need delta y by delta x. So dividing by delta x, we get this. Applying the formula, that is applying limit delta x goes to 0. Since only number comes, that number will be the answer, which is called slope of the tangent line for this curve, which is also called as first derivative. So simply if you differentiate this, you will get this answer. Why I am doing this? Just to tell you, slope of the tangent line and the first derivative are one and the same. Hope now you will slightly understand a little bit more. We'll see one more example to understand it clearly. Question number 2. Find the slope of the tangent line to the graph of f of x is equal to this at the point 5 comma f of 5. If you see the previous sum, general point they have given x naught, f of x naught. Here the point itself is given 5 comma f of 5. So we need to find the slope of the tangent at this point. So what we will usually do? We will consider this as x naught. This is called what? F of x naught, right? This is x naught, f of x naught. So we will try to find what is f of x naught, which is nothing but f of 5. F of 5, what is the meaning? In place of x, put 5 and calculate one value. This is called f of 5. Next, f of x naught I want, right? Which means, what is formula for delta y? Delta y can be written as f of x naught plus delta x minus f of x naught, right or not? So next I am interested in calculating f of x naught plus delta x, where x naught is nothing but 5. So 5 plus delta x. Next I am calculating this. X naught is 5, so 5 plus delta x. Wherever x present, you put 5 plus delta x and then square comes. In place of x, you put 5 plus delta x. Simplify this. A plus b whole square formula. A square plus b square plus 2ab. Bringing 7 inside the bracket, you will get. So bring this 5 inside. You will get these three terms. Simplifying, we get this answer, that is minus 90. How minus 90 means? 125 is combined with the 35 minus 90. Similarly, delta x, if you combine these two, minus 43 delta x, then minus 5 delta x whole square. So what is delta y formula? F of x naught plus delta x minus f of x naught. This is nothing but f of x naught plus delta x minus f of x naught. This is the formula. The formula only I have written because x naught value place we should put 5. Now what is f of 5 plus delta x? We have calculated here. So take this and write here. Then minus f of 5, answer is minus 90. So minus of minus becomes plus 90. And minus 90 plus 90 gets cancelled. If I take delta x as common from these two, minus 43 minus 5 delta x will come. Dividing throughout by delta x comes here. If I divide this by delta x, this and that will get cancelled. So only this remains. Now we will go for the formula. Limit delta x goes to 0. Delta y by delta x is the formula for slope of the tangent. Limit delta x goes to 0. This answer we are having. So take and write it in place of that. Now if you apply the limit that putting delta x equal to 0, this term will fully go, so only minus 43 remains. So minus 43 is nothing but slope of this tangent line. Now if we want to verify, we will take the equation f of x is equal to minus 5x square plus 7x. If you differentiate this, what happens? F dash of x minus 10x, y means 2 will come to the front, 5 becomes 10, power gets reduced by 1, so 1 plus 7x. If you differentiate, answer is 7. At which point they want 5 comma f of 5, right? So substitute 5 in place of x. So minus 10 into 5 plus 7 minus 50 plus 7 minus 43, which is this answer. So first derivative and slope of the tangent line are equal. Again we have proved that. We'll go for the next one. Question number 3. Find the derivative of f of x is equal to minus x square plus 2 using first principle. First principle means again going back to the previous sum. That can be also asked like this, using first principle. Now see how the answer goes. F of x is given. We need to find f of x plus delta x, which means in place of x put x plus delta x and simplify. What is delta y formula? F of x plus delta x minus f of x, right? X naught will come. Here we can just changing x naught to x. Yes or no? The form, what is the formula? Limit delta x goes to 0, delta y by delta x, that is the formula. What is delta y? F of x naught plus delta x minus f of x naught. Here we are writing f of x plus delta x equal to this. Actual formula for delta y is f of x naught plus delta x minus f of x naught. Instead of writing naught, we are putting x. There is no wrong in that. That is why I am calculating f of x plus delta x. Then writing the formula. F of x plus delta x means take this value and write minus, what is f of x? This. So minus f of x means minus of this is f of x. So up to this f of x plus delta x minus f of x. Bringing the minus sign inside and bringing this minus sign inside, simplifying, cancelling, we will get delta y as this. So divide, when delta y comes, we should divide it by delta x. So dividing by delta x on both sides. Here square will reduce to delta x. Here delta x will go because we are dividing. How the step comes? Divide by delta x. We get this. Now apply the limit. Limit delta x goes to 0. Delta y by delta x is the formula in which delta y by delta x can be replaced by this value. Now apply the limit. Delta x goes to 0 means the first term fully will go. Only minus 2x remains. So the first derivative answer is f dash of x is equal to minus 2x. Now if we differentiate directly, f of x is equal to minus x square plus 2. What is f dash of x? Use the formula x power n. Power will come to the front, so minus 2. Power will get reduced by 1, so x power 1. If I differentiate the separate constant, answer is 0. So directly I am getting this answer. So directly we know the formula, but using first principle, if you want to prove, means you should do like this. So find f of x plus delta x. Find out delta y. What is delta y? F of x plus delta x minus f of x. So subtract these two. You will get delta y. Divide by delta x so that you get this. So apply the limit and find out the answer. Directly if we apply the formula, we will, in one step we will get the answer. But using first principle they asked means you should do only like this. Go for the next sum. Problem number 4. Find the derivatives from the left and from the right at x is equal to 1 if they exist of the function f of x is equal to modulus of x minus 1. So always we will read out the question once again. Find the derivatives from the left and from the right at x is equal to 1. The meaning is we need to find left hand limit and right hand limit. That is the meaning. We should find left hand limit as well as right hand limit at the point x is equal to 1. If they exist, the function is given f of x equal to modulus of x minus 1. For doing this kind of problem, that is to find a first derivative, that is left hand limit and the right hand, find the derivatives from the left. The meaning is left hand derivative and right hand limit we need to find out for the first derivative. So we should know this formula. This is the formula that you have to memorize. So this is the formula for first derivative. Finding first derivative we can do like this. F dash of a is equal to limit. F dash of a means, what is the meaning? We are differentiating this function. If you differentiate f of x, I'll write here. If we differentiate f of x, the answer will be f dash of x. Differentiating at a particular point, then we will call it as f dash of a. While we differentiate, we will get this. What is the meaning of this? What is the differentiation at this particular point? At this particular point, that is when x is equal to a, what is the value? That is called f dash of a. Here, the point is x is equal to 1. Now, this is the general formula for finding first derivative at a point. So f dash of a can be written as limit x goes to a, f of x minus f of a by x minus a. So first learn this formula, then we can do the problem. Here I have written f dash of 1 minus, a value is 1 we know because the point is given to us. 1 minus, the meaning is we are trying to calculate left hand limit. If I write like this, left limit, that is the meaning. Okay, now I am going to apply the formula. Limit x goes to a means I will write 1 minus, what is f of x? Modulus of x minus 1. So in place of f of x, you substitute this minus f of a, where a is 1. So when you substitute 1 here, 1 minus 1 will come, right? So this is f of x minus f of a means a is, since a is 1, 1 minus 1 will come by x minus, in place of a putting 1. Hope you will understand this. Then limit x goes to 1 minus. Now see the modulus. Modulus means we have two things. Modulus of x minus 1. What is the meaning? Modulus of x minus 1 has two values. One is directly x minus 1. Other one is minus of x minus 1. Why we are having two values? If x is greater than 1, that is if x is greater than 1, that is 2 or 3, the value will be taken directly. If x value is lesser than 1, that is minus 0 or if 0 comes, what happens? Minus 1 will come. So modulus means positive, so we will add one more minus. So to make it positive, we will add one more minus, that is called minus of x minus 1 if the value goes below 1. Try to understand very carefully. Modulus of x minus 1, what is the correct definition? Modulus means two values. One is the direct value, other one is negative of that value. When we can take the direct value, if positive answer comes. When positive answer will come, if this x is more than 1, positive answer will come, so direct answer. When this gives negative answer, if x is lesser than 1, for x lesser than 1, this answer will be negative. So to make it positive, we will add one more minus. So modulus functions will have always two values. One is the direct value, other one is negative value. Here, if x is more than 1, direct value, x is lesser than 1 means negative value. Now if you see 1 minus means, what is the meaning? Value which is lesser than 1. 1 minus means value lesser than 1. So value lesser than 1 means what we have to do? We should take this function minus of x minus 1. That is why this modulus function is written as minus of x minus 1. And this will become 0. This x minus 1 I have written. So these two will get cancelled. So only minus 1 remains. When I apply the limit, since the number comes, this number is the answer for this limit. So first derivative of left hand limit value is minus 1. Next we calculated left limit, then we have to calculate right hand limit, which means what is the formula? F dash of 1 plus. If I write 1 plus, that is called right limit. I am calculating the right limit. Again the same formula, limit x goes to, in place of a 1 plus, formula is f of x. F of x value is given in the question, so write that minus f of a 1 minus 1 by x minus a, so x minus 1. Everything comes from this formula. So from this formula I have written this. This is equal to limit x goes to 1 plus. Now see, 1 plus, what is the meaning? More than 1. 1 plus more than 1. So greater than 1, that is the meaning. 1 minus, what is the meaning? Less than 1. Values lesser than 1. So 1 plus means more than 1. So more than 1 means if x is more than 1, what is the modulus function? Direct value x minus 1. So this value will become x minus 1. This becomes 0 and x minus 1. Both will get cancelled. So if I cancel both, answer will be 1. So when I apply the limit, since the number only present, we cannot, since if x is there, I can use 1. So only number comes, that will be the answer for this. When I take limit for a number, the number will be the answer. So 1. What is this 1? Right hand limit. First derivative at right limit of first derivative, f dash of 1 plus. Answer is 1. What is f dash of 1 minus? Minus 1. Now they are not equal. The left limit is not equal to right limit. But what we have to know is, for a function to be differentiable, our chapter itself includes a heading differentiable. To say, listen carefully, to say a function is differentiable at a point, we should have the condition that both left hand limit and right hand limit should be equal. Then only the function can be said to be differentiable at a point. Since left hand limit and right hand limit are not equal here, f dash of 1, that is first derivative of this function at the point 1, does not exist. The first derivative does not exist. What is the reason? Left hand limit and right hand limit are different. Therefore I should say that the function f, that is this function, modulus function, the modulus function f is not differentiable at x is equal to 1. This is not asked, we are writing f is not differentiable at the point x equal to 1. Could you able to understand? So the function is not differentiable at the point x is equal to 1. The reason is left hand limit answer and right hand limit answer are different. They should be equal to say a function is differentiable at that point. At the point 1, the left limit gives another answer, the right limit gives different answer. So the function is not differentiable at x is equal to 1. I hope you will understand this. Go through the video once again, then you can easily understand. Thank you, children.